Welcome to Environmental Science and Engineering Videocasts. Okay, so today we're diving into something we all do, literally every second of every day. Breathe. But what if the very air we depend on is hiding a crisis? An invisible one? Yep, we're talking about air pollution.
So before we can even get into the pollution part, we got to understand the air itself. I mean, the atmosphere is this incredible mix of gases, right? It's what makes life here possible. It's mostly nitrogen and oxygen, but you see that tiny little 1% sliver of other gases? Well, that's where our story really begins.
And here's the thing. That tiny sliver is changing, and that's the huge problem. Our activities are seriously disrupting this natural balance. I mean, just look at carbon dioxide. Before the Industrial Revolution, it was stable, sitting around 280 parts per million. Today, we're way up at 420. That's a massive jump, and it's not just a number on a chart, it's a major driver of the climate crisis.
So, what's causing this imbalance? Well, it's driven by a handful of key pollutants. Let's go ahead and meet the main culprits behind our declining air quality.
All right, first up, we've got carbon monoxide, or CO. You've probably heard it called the silent killer. And for a chillingly simple reason, you literally can't see it, smell it, or taste it. That's what makes it such an invisible threat, you know? It's impossible to detect without special equipment.
So where does it come from? It's produced by something called incomplete combustion. Basically, that's when a fire doesn't get enough oxygen to burn cleanly. Think about car exhaust, or maybe a faulty stove. Now, here's why it's so incredibly dangerous. When you breathe it in, CO actually latches onto the hemoglobin in your blood, and it blocks oxygen from getting to your cells. That's carbon monoxide poisoning. And yeah, it can absolutely be lethal.
Okay, moving on. Next up, nitrogen oxides. This is a whole family of gases we just call NOx. Honestly, you can think of them as a staple of modern city life. They're formed anytime fuel is burned at really high temperatures. We're talking everything from the exhaust of our cars to the big emissions from power plants.
And their impact? Oh, it's widespread. NOx irritates our lungs, it makes asthma way worse, and it reacts up in the atmosphere to form acid rain. Plus, it's a key ingredient in that nasty recipe for photochemical smog. Diesel engines in particular are pretty notorious for pumping out high levels of NOx.
But there is a pretty clever solution for this, at least in modern diesel engines. It's called AdBlue. So how does it work? Well, a special liquid, it's basically urea and purified water, gets injected into the hot exhaust. This kicks off a chemical reaction that breaks down those harmful nitrogen oxides, and get this, it converts them into simple, harmless nitrogen gas and water vapor. It's actually a really neat piece of engineering when you think about it. All right, our next pollutant is sulfur dioxide, SO2 for short. This one you can smell. It's got this distinct, sharp odor, and we usually associate it with heavy industry. It gets created whenever sulfur-rich fuels, especially coal, are burned.
So the biggest sources are exactly what you'd think. Coal-fired power plants and big industrial processes like metal smelting. And just like NOx, it's a major respiratory irritant. It's also one of the main components of acid rain because it reacts with water in the atmosphere and forms sulfuric acid. Nasty stuff.
And finally, let's talk about ozone. Now this one's a bit of a paradox. It's kind of got two faces, like a Dr. Jekyll and Mr. Hyde situation. High up in the stratosphere, we have good ozone. It forms a protective layer that shields us from the sun's harmful UV radiation. Absolutely essential. But down here at ground level, where we live and breathe, that's where we find bad ozone, and it's a really dangerous pollutant.
And here's the crucial thing. This bad ozone isn't actually emitted directly from a tailpipe or a smokestack. Nope, it's kind of cooked up in the atmosphere. It happens when nitrogen oxides and other compounds react in strong sunlight. And that reaction, that's what creates that hazy, brown photochemical smog and gives you that burning sensation in your lungs on a hot, sunny day in the city.
Okay, so we've met the main pollutants. But what's really wild is how their effects can be magnified, like dramatically, by the weather. So what happens when the atmosphere itself decides to trap all these pollutants right down where we live?
Well, that phenomenon is called an inversion. And what it does is it essentially puts a lid on our cities, and it stops that pollution from escaping.
So how does this lid even form? Well, normally, the air near the ground is warmer, right? So it rises, taking pollutants with it and dispersing them. Simple. But during an inversion, things get flipped upside down. A layer of warm air settles on top of cooler air near the surface. This warm layer acts like a cap, trapping all that cold, polluted air right underneath it.
And this trapping effect, it can turn what was a local pollution problem into a full-blown regional health crisis. So when we zoom out and look at the global picture, well, the data is honestly pretty alarming.
So, according to the 2024 World Air Quality Report, the vast majority of us are breathing unsafe air. And the key number here is, it's just staggering. Only 17%. Think about that. That's the tiny, tiny fraction of cities around the world that actually meet the World Health Organization's air quality standards.
And you can really see this stark divide when you look at the country-by-country data. On one side, you got countries like Norway and Finland with really high air quality, and that's largely thanks to strict regulations and a big push into renewable energy. But then on the other side, you have countries like Chad and Bangladesh facing just severe pollution, often because of a heavy reliance on fossil fuels and rapid, sometimes unchecked industrial growth.
So where is all this pollution coming from anyway? Now we often point the finger at energy and industry, and for good reason. But here's a major contributor that's often overlooked: agriculture and livestock. You know, things like fertilizer use and methane emissions from animals can account for up to 20% of the entire problem. It's a huge piece of the puzzle. You know, the world wasn't always this aware of the dangers. It actually took some truly catastrophic events to serve as a massive wake-up call, one that forced society to finally confront the lethal reality of air pollution.
Two events in the middle of the 20th century were absolutely pivotal. First, you had the 1948 Denora smog disaster in the US, and that was followed just a few years later by the 1952 Great Smog of London. I mean, these tragedies killed thousands of people, and they directly led to the creation of landmark environmental laws, like the U.S. Clean Air Act, a law that still protects Americans today.
Let's start with Denora, Pennsylvania. It was a small industrial town that was, well, it was literally suffocated for 5 days straight. That thermal inversion we talked about, a really strong one, trapped all the toxic emissions from the local steel and zinc plants right at ground level. Over 20 people died, and thousands more got sick. It was really the first time the deadly consequences of modern industrial air pollution were laid bare for everyone to see.
And then, just 4 years after that, an even greater tragedy struck London. It was this perfect storm of cold, windless weather and just massive amounts of coal smoke. It created this thick, toxic smog that just blanketed the entire city. Public transport ground to a halt, visibility dropped to just a few feet, and thousands of people died. It was a public health catastrophe, and it forced immediate action, leading directly to the UK's very first Clean Air Act.
So, these disasters, as terrible as they were, they forced a new awareness and really created the foundation for modern environmental law. The kind of visible, choking smogs of the past, they've been largely regulated away in many parts of the world, which is great. But the challenge has evolved. Now we're dealing with invisible threats, things like fine particulate matter and that ground-level ozone we talked about. And it leaves us with a pretty crucial question. The world woke up to the obvious, visible dangers of the 1950s. But are we fully awake to the invisible threats we face today? Don't forget to subscribe to the channel.